Hello everyone, this is Ansh and today we are going to start with our next topic, that is row chaining and row migration. So row chaining and row migration, this is very important topic, and this is basically used during the performance tuning. So if you notice some poor performance in your database, so row chaining and row migration is one of the main reason which can play an important role in degrading the performance of a database, and this can be caused due to the poor application design or some database design. So according to this row chaining and row migration, these are the two different concepts. What happens in row migration and row chaining, we'll discuss in our today's session. Okay, so we'll discuss in about row chaining and row migration, and then how to identify row migration and row chaining is happening, and what are the use cases, how to avoid the row chaining and row migration. So first of all, everyone should be aware with the Oracle blocks, and Oracle blocks is basically a smallest entity where physical data used to resides, and the smallest entity, or smallest block, is the OS block, which is the physical in aspect. It is being residing under the OS level. Apart from that, we have to understand about the row chaining and row migration concept. So we'll start with the row migration one. So what happens here? Let me show you. Suppose if we are using a block, everyone is aware that we are storing our data in the blocks, and say the default block size is 8 KB. So when a row is present in a block, suppose if you are keeping the data of a particular table, and if you're keeping the data of a table, say emp has 14 rows, so all the 14 rows will be residing under any of the blocks, right? So suppose in this block we have one or two or three rows which is present in this block, and the block size is 8K. Okay, so what happens when this row, one row named as column name is Ram and his salary is 2K. So this information is being stored in this block. So if this information is stored in this block, that means what? This block is also containing the informations of that particular row in form of row ID. So that row ID is also present in this block. In some scenario, what will happen, as we know that row ID is the fastest way to access a particular row, and it is uniquely identifiable, right? So what will happen if you want to migrate a row, when an update or some DML operation you have triggered, say suppose this row, the salary of 2K, you want to update it to 10K, right? Okay, so what you are doing, you are triggering the update statement. Earlier the RAM details were present in this block, RAM with 2K salary, right? Now you want to update it to 10K. What will happen? What will happen here? So a migration, if you are updating something, right, to a particular row, so in this case it might happen the row is not as much capable to store 10K salary data in this row ID, right? This block is around 8 KB, and this much information is already stored for a particular row. If you are doing updating means you are updating the salary to 10,000, which would not fit in this row. On that scenario, what will happen? You want to update it, right, but you don't have sufficient space in this block. So on that scenario, keeping the information of this row as a row ID, it will migrate the information to another block, and keeping the information, that is the remaining information which will be present in this block, and the other information will be present in this block. And how to differentiate, how to similarize these two blocks, that half of the information of a one row is present under this block and half of the information is present in this block. It would be decided on the basis of row ID, because here row ID will keep intact with the other blocks, which will uniquely identify that the row ID for this row is also present in some other block. Okay, so whenever you will fire this command select star from emp, where name equal to ram, so in this scenario what will happen, these two blocks as a whole will be taken by the server process and will be moved to the database buffer cache to display the output. So always remember, row migration is just a process where if update statement is happening on a particular block on particular row, and the block is not capable to store the data inside that 8 KB, so it will migrate to another block with the updated details of the particular row, keeping row id as a referential reference to keep the information that both the blocks has the same information of a particular row which is in the table. So this is what we call as a row migration. So in this scenario, what will happen in the migration case means the entire row can be migrated to another block, keeping the informations on the other block, saying that okay, the half of the information can be present in the different type of blocks. Similar way, if we are talking about row chaining, if we are talking about row chaining, in row chaining, what happens if a row is too large to fit in a single block? That means, suppose you can say this is a 8 KB block and a single row size is around 12 KB or 10 KB. So on that scenario, a single block cannot store this information in this row, in this block. This 10 KB information of a single row can't be stored in this block. So what will happen here? This row is too large to fit in a single database block. Okay. So in this scenario, Oracle will have to use another 8 KB blocks to store the information of a row. Okay. So in this scenario, if table whose row size exceeds the block size, then in this scenario we have to do row chaining, means keeping half of the information in this block and keeping half of the information of a particular row in this block, keeping row id as a referential path, that this block should know that half of the information is present on different block, and this block should be knowing that half of the information is present on different block. So after certain period of time, if the space is less or data is not getting inserted anymore, so the data which is not stored in this data block due to some reason, due to some insufficient space, will go and save it to the new block. And if it is going to save in the new block, making as a chain by keeping half of the information in one block and keeping half the information in another block, that means it's chaining something, right? Chaining of block is happening here. So what we call as a row chaining. And similarly, in row migration, what will happen? The entire row which is not able to fit after updation, the entire row will move to a different block. That means only one block is required to store one specific row information. But in this scenario, if block is too small to fit a row size, then we have to chain it to store in the pieces. Okay, 2, 2, 3, or 4 or 5 blocks is required to store a single row. We have to store that then. So this is the concept of row chaining and row migration. And for this, row ID is the reference, is the center point of attraction, which stores the referential information about the row. It might be present on any row. So row ID will allow you to know that okay, this information, half of the information of a particular row is present on which block. So this is a concept of row chaining and row migration. We have the practical scenarios also. If you want, I can circulate with you guys. So this is it from my side from row chaining and row migration. Thank you everyone. Bye bye. Take care.